Do you know which one is the hardest circle theorem? Well, this is number 7. Even though it's the hardest one, luckily it does have a name, so you just have to memorize that. It's the one that's called alternate segment theorem. So there's a lot going on here. If you have a question that doesn't have a tangent, it doesn't have this straight line on it, then you can at least not worry about it. But if you do have a tangent, you might need to use this one. So we've got here that the angle between a tangent and a chord is equal to the angle in the alternate segment. Now, they're not going to ask for that explanation in the exam. If they've asked you to give reasons for each stage of your working, you would just write down alternate segment theorem as your explanation. Don't worry about literally explaining it. The thing that I look out for is a tangent, so this straight line that just comes and touches the circumference of the circle and then carries on. And then we've got here 3 chords, but effectively they create a triangle, don't they? So you're looking for a tangent and then a triangle where all 3 corners are touching the circumference of the circle, first of all. Secondly, that one of those corners is also touching the same place as the tangent. If you have that scenario, then it's likely that you can use alternate segment theorem in your working. The next thing to then be aware of is, okay, I've got this scenario, I can use this, but how does it work? A lot of students get mixed up with angles on parallel lines where you have the one that looks a bit like a Z, and they think that these 2 angles are the same. That is not the case here because, as I said, angles in parallel lines. We don't know if this chord is parallel to the tangent, and we're pretty much assuming that it's not going to be. It's unlikely. I know it kind of looks like it is here, but it's most likely not, unless they tell you, which again I don't think would happen. So that is not the case. Do not get mixed up with that little Z formation. Whenever they say alternate to do with angles, it normally means opposite. So the way I like to think about it is I go, okay, this angle, that's fine, that's quite easy. So it's the angle between the outside of the triangle and then your tangent. That's quite easy to identify. Is the same as the opposite angle in my triangle. So all the way over here, do you see how that's opposite? The one here is not opposite. It's basically on the same side, isn't it, if you think about it that way? So it's on the opposite side. If you need to rotate your exam paper so that you can look at the tangent at somewhere near the bottom and it makes a little bit more sense, feel free to do that. So this angle is the same as the one outside the triangle and the tangent. Now, it also works in the other direction as well. So for example, this angle between the outside of the triangle and tangent is the same as the opposite angle inside the triangle. Okay, so let's say that's Y and that's Y. Those are also the same. It works both ways, whichever is convenient for you. If you found this helpful, make sure to check out the GCSE Maths Pro YouTube channel where you can find full videos going through everything that we've just seen.